is going to contain some practice problems with Rolle's theorem and mean value theorem, so that you'll get a good feel of what those theorems entail, as well as how to apply them. So just a reminder, Rolle's theorem is this specific case of mean value theorem. So we have to remember that Rolle's theorem, we must be continuous and differentiable. And the specific case for Rolle's is that, remember, those y values have to be equal to each other. So I think that's a good reminder for Rolle's theorem. Okay, let's look at problem number 1. So I don't really have a problem on number 1 with continuous or differentiable. It's going to be a nice x squared, so it's a parabola of some sort. I am going to check to see if those y values are the same. So I need to know the function at 0 and the function at 4. So at 0, I get 0 squared minus 4 times 0, just still 0. And then I get 4 squared minus 4 times 4. So that's 16 minus 16, and that also gives me 0. So I know that Rolle's theorem applies. So now let's find the value, right? We're told that we're guaranteed a place where the derivative equals 0. So let's find the derivative. Be 2x minus 4, and we know that that's where it's going to equal 0. So let's see, that's 4 equals 2x, x equals 2. That's my value that's guaranteed by Rolle's theorem. Okay, let's look then at number 2. Again, I don't have a problem with the continuous or differentiable. I am concerned about the y values, so let's take a look. At -4, I'm going to get, oops, so that's a -4 there. I'm going to get 0. And at 3, I'm going to get 0 also. So I know that Rolle's theorem applies. So now let's go ahead and take the derivative. Looks like I've got a good product rule going on. That's going to be the first times the derivative of the second minus, plus the second times the derivative of the first. Now those look like they both have an x plus 4 in common, so I'm going to go ahead and pull that out. That's going to leave me with an x plus 4 and a 2 times x minus 3. And I'm just cleaning up my derivative here because I know I'm going to set it equal to 0. It's going to make it a lot easier if I have it cleaned up. Distributing that 2 there. Now working in that second parentheses, it looks like I have 3x minus 2. Now I set this equal to 0. And the first value I get x equals -4, which is on the closed interval, but not on the open interval. And the other value I get is 2/3. And so the x equals 2/3 is the value that's guaranteed by Rolle's theorem here. Okay, look at number 3. I don't have a problem with the continuous. Think about this as going to be an absolute value graph just turned upside down. But we know with absolute value, we have a problem with being differentiable. So here, Rolle's theorem doesn't apply. Because f of x is not differentiable at x equals 2. And that's because we have that corner there, right? We have that corner of that absolute value graph. Let's look at then at number 4. We have sine of x, no problem there with being continuous or differentiable. And let's look at the y values, f of 0. Sine of 0 is 0. And f of 2 pi, sine of 2 pi is also 0. So Rolle's theorem applies. So let's find the value then. We're going to set the derivative, take the derivative. and then set it equal to 0. And on the unit circle from 0 to 2 pi, where is cosine equal to 0? Well, that's where x is equal to 0. So that's where x is equal to pi. And that's the value. Now, cosine is also equal to 0 at 0 and 2 pi, but again, those are on the closed interval, not the open interval. So we'll leave it at x equals pi. Okay, looking at number 5 then, cosine of 2x being my function. Again, no problem with being continuous or differentiable, but we're going to need to check those y values. So f of pi over 3 would be cosine of 2 pi over 3. Cosine of 2 pi over 3 is over here in quadrant 2. It's a 60-degree reference angle, so cosine is negative 1/2. F of 2 pi over 3 would give us cosine of 4 pi over 3, which would be in quadrant 3. And so cosine is also going to be negative 1/2. So we know that Rolle's theorem applies. So let's find the value. We're going to take the derivative, which will be negative 2 sine of 2x. And we'll set it equal to 0. So I've got that 0 equals sine of 2x. So think about on the unit circle where sine equals 0. That happens at 0. That happens at pi. And that happens at 2 pi. So notice that I'm setting these values equal to 2x. Setting them equal to 2x. And that's because there's a 2x inside of the sign. So I end up with x equals pi over 2 and x equals pi. Now both of these values are on, I'm sorry, just this value is the one on the interval that is guaranteed by Rolle's theorem. Let's switch our attention now to mean value theorem. Okay, so mean value theorem has some of the same conditions. You still have to be continuous, the function does. It still has to be differentiable, but we don't have to have those y values being the same. That's a lot nicer. But remember what the mean value theorem guarantees us, that the derivative at some point on the interval is equal to the average rate of change. If you saw my previous video, it was the slope calculus way equals the slope algebra way. Okay, so let's check here. I'm pretty good with continuous and differentiable there. Don't see any problems. So I'm going to find my derivative. That'll be 3x squared minus 2x minus 2. And we want that at c. And then we need the slope the algebra way. So I need f of 1 minus f of negative 1 over 1 minus negative 1. So f of 1 is 1 minus 1, which is 0, minus 2 is negative 2. Put in negative 1. I've got negative 1 minus 1, which is negative 2, plus 2, which is 0. Forgive me, this is a negative 1, not a negative 2. I was thinking ahead. This is 2. So I get negative 1. So I'm going to set my slope calculus way equal to my slope algebra way. And now I'm going to solve. I'm going to bring over, there we go, my negative 1. And let's see if I can factor. I think I can. There we go. And then set each one equal to 0. And remember, the one that's guaranteed is the one on the interval. And that gives me c is equal to negative 1/3. Okay, now let's look at number 7 here. On this interval, I don't have a problem with being continuous or differentiable. So let's go ahead and take the derivative. Think of your function as x minus 3 to the 1/2. So that gives me 1/2 x minus 3 to the negative 1/2, or 1 over 2 x minus 3 to the 1/2. And again, we don't have a problem on this interval with being differentiable or continuous. We do on other intervals, but that's not our problem here. And then let's find we'll find the slope algebra way. We're going to do f of 7 minus f of 3 over 7 minus 3. So f of 7 would be the square root of 7 minus 3, which is the square root of 4, minus the square root of, minus square root of 0 over 4. So let's see, that's 2 over 4, which is 1/2. So let's set that equal to 0. Nope, let's set that equal to each other. Get so caught up in setting equal to 0, sometimes that's all we say. All right, friends, cross multiply here. I'll divide by 2. And then I'll square both sides. And you get c equals 4. That's the value that's guaranteed by the mean value theorem here. Okay, let's keep going. We've got number 8 here. I see a problem with being I see a problem with being continuous at x equals 0. That's not on this interval. I see a problem with being differentiable at x equals 0, but again, not on this problem. So let's go ahead, not on this interval. Let's go ahead and take the derivative. I'm going to rewrite my function as 1 plus 2x to the negative 1 by dividing both of those. It's going to be a little bit easier to take my derivative of that. So derivative of 1 is 0. I'll bring the 1 in front, negative 1 in front. And we're finding this at c. So I've got negative 2 over c squared. Then let's find the function at 1/2. Oops, sorry. We're going to do f of 2 minus f of 1/2 over 2 minus 1/2. So f of 2, 2 plus 2 is 4. 4 divided by 2 is 2, minus 1/2. So 1/2 plus 2 is 5/2, divided by 1/2. 5/2 divided by 1/2. Flip that and multiply. That's going to give me 5. And then 2 minus 1/2 gives me 3/2. And again, flip and multiply here, you're going to get negative 2. So let's set that equal to 0. I got negative 2 over c squared equals negative 2. Cross multiply. Divide by my negative 2. So c is plus or minus 1. Now the one that's guaranteed on this interval is c equals 1. All right, one more here. I don't have a problem with differentiable or continuous on this interval. So let's go ahead and jump in and take the derivative. That would be negative 2 sine of x plus negative 2 sine of 2x. And I want that at c. Okay, now let's find the slope. So I've got h of pi minus h of 0 over pi minus 0. So h of pi, cosine of pi is negative 1 times 2 gives me negative 2, plus cosine of 2 pi is 1. Now let's do h of 0. Cosine of 0 is 1, so 2 times 1 is 2, plus cosine of 0 is still 1, and that's over pi. Okay, so I've got negative 2 plus 1, it's negative 1, minus 3 is negative 4, so I get negative 4 over pi. All right, so I want to know where negative 2 sine of c plus negative 2 sine of 2c equals negative 4 over pi. Now, this is going to require our calculator. So I'm going to switch over to my layout that has my Desmos calculator on it. So we can take a look. We're going to put, I'm probably going to go ahead and put, let me think if I want to put this in -2 sine of x. And by the way, don't forget, we learned this in another video. Got to put parentheses around that sine of x. -2 sine of 2x. And then on the other one, I'll put -4 over pi. There we go. And I just typed pi, by the way, just so you know. And that's not going to, I want to find the intersection of them. So let's do it this way then. Let's go here and I will move this over so that I get -2 sine of c plus -2 sine of 2c plus 4 over pi. And then we'll find out where that's equal to 0. That'll do the same thing, minus 4 divided by pi. There it is. And we're trying to find out where this equals 0. Looks like I accidentally put a minus in there instead of a plus, so let's fix it. Oh, that looks so much better. So friends, I have two values here. I've got this one value here. So let's see, C is 0.217. And then I've got another value that's on this interval here, which is 1.748. Now, there are other values where this equals 0, but not on this interval from 0 to pi. And that's why I'm not including the others there. Okay, let me go ahead and switch us back to this layout so we can finish up our practice problems here. This is asking us, here's a graph of the function. We're being asked if these theorems apply. So let's look at Rolle's theorem first. They're on the interval from -5 to -1. Rolle's theorem does not apply because it's not continuous, right? We've got a hole right there at x equals -3. And I can spell continuous sometimes. All right, friends, let's look at the Rolle's theorem again from -2 to 8. So from -2 would be here to 8 would be here. Is it continuous? Yes. Is it differentiable? No. So Rolle's theorem doesn't apply this time. Because f of x is not differentiable. At x equals -1. Okay. And then the last one, mean value on -1 to 8. Is it continuous? Is it differentiable? Yes. Mean value theorem applies. Because f of x is continuous on -1 to 8. Ah, and differentiable on -1 to 8. So I hope that helps with these practice problems. Let me know in the comments below if there's anything else you'd like me to explain a little bit better or you'd like to see more problems like this. Bye for now.